But good morning, everybody. It is Thursday morning, and class has started. I'm so glad you guys are here. I hope that you're warm. I opened up my blinds this morning, and there was snow on the ground, and it was freezing. So hope you guys are doing okay. Take a second and finish up this little warm up. And I want to be able. We want these are kind of the essential skills that we're dealing with, and just want to make sure you guys are okay with that, so we don't get stuck on this later on. Okay, so just take a minute and see how many of these you can get done, and we'll talk about them. Okay. All right, guys, it's been a couple of minutes, so I'm going to go ahead and go over this. Remember, it's okay if you're struggling, or it's okay if you're a little lost. What needs to happen then, though, is we have to make sure that by the end of this, you guys have an understanding what we're doing and you feel a little bit more comfortable. Okay? So these are they're connected, and they're connected by the number 100, right? So a percentage is out of 100%. So but we write 100% as 1 as a decimal. So sometimes it can be confusing what we need to do. So if we already are in a percentage is out of 100, whereas a decimal, right, is out of 1. So to convert from a percentage to a decimal, we're going to take our percentage and we're going to divide by 100. And the way that this reads, guys, is 27 out of 100. That's 27%. Okay, so if you think of it as a fraction, that's all you need to do to be able to convert it to a decimal. It's 27 out of 100. That is 27%. So on my calculator, I'll go 27, right, divided by 100. Okay, so I get 0.27. Okay, so it's I think it's really nice to think of it as a percentage is out of 100%. So it's 27 out of 100%. Okay, that's 0.27. And so that's a really easy way to remember, how do I get from percentages to decimals? So again, for 7%, that is 7 out of 100, right? So it's 7 out of 100, that's 7%. So then if I type that into my calculator, and here I did the division. If you have a fancy calculator and it can do fractions, you can do that too, right? It's the same thing. A fraction is division. Oops. So here I'm going to have to hit the little double arrow button to get it as a decimal. So I'm going to have 0.07. Notice how there's that 0 there, right? Because this is the tenths place, and there is no tens number, right? This isn't 17 or 27. So there is no tenths number, so it's 0.07. Okay? So that's what's going on there. And then again, guys, please remember, ask me questions. If you're like, Kraft, I'm confused, I don't know how you did that, or I did this and I got something different, I want to help you. This is what this is about. Imagine us we're sitting together, right? We're in person. That's what we would do if we were in person, right? We would talk to each other and be like, how can I get this right? Okay, so now when we're going the other way, right? So a percentage, right, is 27 over 100. Well, you can think of these as algebra equations, right? So if I'm dividing by 100, right, and this is my percentage, I want to move the 100 over here, right? So if I'm dividing here, what's the opposite of dividing? Multiplication. So I'm going to do the opposite, right? Because I'm going the opposite direction. So here, I'm going to take 0.67 and I'm going to multiply by 100. Okay, so if I multiply by 100, I'm going to get 0.67 times 100, and I get 67%. Okay. So it can be confusing because you go forwards, you go backwards, right? I don't know about you guys, but running forwards is really easy. But then you try to run backwards and we're starting to fall over the place, right? So it is confusing when we switch going back and forth, okay? And then here, I'm going to take 0.051 times 100, and let's see what we get. So I'm going to get 0.051 times 100, and I get 5.1%. Okay, like that. Oh no. Hey, I'm sorry. Someone sent me a chat, guys, and I really want, it's important to ask that. So you can't hear me. Is that what you're saying? Okay, so yeah, so I totally agree. So you can't hear me, so I'm going to write everything down. Okay, so thank you for letting me know. I appreciate that. Okay, so that's what's going on here, guys. So we're going percentage to decimal, we divide by 100, and if we're going from decimal to percentage, we multiply by 100. Okay. All right. So today we're going to, this is our third day on exponential growth. We're going to work more on word problems today. Hopefully, are you guys doing your homework right? Right. So are you guys doing your homework? Okay. Did you do your homework, right? And make sure if you need help, to email me or come to office hours. Okay, guys, I would really like to help you. Right, and so someone just said it was sort of confusing. Guys, I get that. When you're learning something new, it's gonna be confusing, right? Or else we would learn everything super quick. And 50-minute classes, they aren't long enough, right? They aren't long enough. So it's gonna be really important that you guys, we have to be able to talk, and we have to be able to work through that confusion together. So it's almost like you guys should always be emailing me, right? Because of course you're going to be confused. Okay, 50 minutes isn't enough time together. So, right, like we're in an extended class. Normally we would have 84 minutes together every day. Hey, and I really appreciate that. And people are talking about like, hey, like we're getting it done, right? And I know you guys are working hard. I know this is difficult, and I respect you so much for working so hard and getting this done, okay? But just remember, keep working on it, right? Keep doing it. Don't lose hope. Don't get frustrated, okay? And if you do get frustrated, email me, okay? Email me, guys, because you're not in this alone, okay? You're not. I'm here to help, okay? And that's super important that you guys know that. Okay, I don't want you guys struggling and thinking you're the only one who's struggling. Okay. All right, so what we're going to do now today is we're going to do more word problems. Okay. And today in your homework, this is going to be the first homework where you have a word problem in it. You guys really haven't had a word problem in your homework yet. Okay? So we're going to do some more word problem, and hopefully that was enough to get down this. Okay? Okay. So let's do another, I'm going to do another word problem, and then we're going to break it up into parts. Okay? So here's our first word problem. Okay. We're going to write a function. Okay, write a function for the population of a city. And I'm going to slow down. So we're going to write a function for the population of a city. And guys, I get it, right? Like school is tough, right? With everything going on. So I appreciate you guys working hard on that. So write a function with the population of a city that currently has 50,000 people. And is growing at a rate of 3.2% each year. Okay, so this is our start. So get this down. Right? We're going to write a function for the population of a city that currently has 50,000 people and is growing at a rate of 3.2% each year. So it might be helpful, and this is why I hope you guys are taking notes, because remember, all of your homework assignments and our final, they're all going to be open notes. So hopefully you guys have in your notes, right, the equation for growth. You guys remember it? So we had y equals a times 1 plus r to the t. Right, where this is our final population. This is our start population. This is our rate as a decimal. And this is time. And you guys already have this written down. So if you're like, hey, I already have this written down, good. Just make sure you know where it is in your notes. And if you don't have it written down, you should, because remember, everything we do is open notes. So I'm going to give you guys a minute, because we're just plugging in numbers. So I'm going to give you guys a minute to write that equation. Okay? So we're going to write a function, right? So this is what we're doing right now. We're going to write the function just like this. I'm going to give you 1 minute. All right. So let's take a look, right? So this is our first step. We're going to write an equation. So my equation, right, is going to be, I'm going to have y equals, okay, that's right. I'm going to have a y equals, and then my start amount, right? My start amount A, that's 50,000 people. So I'm going to write 50,000. Okay. So again, it says here, this is my start amount. So then I currently have 50,000 people. So that's where it's going to go there. That's my start. That's the only data I have, right? So they gave us this number. That's what we have. We have our start amount. So I have 50,000 people. Then I'm going to have parentheses. And then remember, the one represents I'm keeping my initial amount because that's growth, right? So that's what this 1 represents. And I know a lot of people are like, what's the 1? The 1 stands for 100%. So I keep 100% of my current people because we're growing. Now we're going to talk about, starting next class, we're going to talk about decay, where I lose people, right? People are moving. So right here, this 1, this represents I'm keeping the initial amount. And then I'm going to add my percent as a decimal. But I need it as a decimal. I need a decimal. So I'm going to take 3.2% and I'm going to divide it by 100. Right? Because this is 3.2 out of 100. That's what this is. Okay? It's 3.2% just means 3.2 out of 100. So if I grab a calculator and I type this in, and some of you might be seeing the shortcut that I'm really just moving the decimal over 2 places, but that's okay if we don't. So I get 0.032. So I'm going to take this answer and plug it in here. Okay. This is my equation. Okay, and that's it. Does anybody have questions or comments? Okay. So now that you have your equation, the second part here is I want you to estimate the population in 10 years. Oops, not 11, 10 years. And I'm going to say to the nearest person. So we're going to round to the nearest person. So what I want you guys to do now is we have this equation. So I want you to estimate the population in 10 years. Now remember, 10 years, that's going to be our t. Right? So see how our t is right here? So in 10 years, that's going to be our t. So I'll give you guys a minute to type that in and see what you get. And I'm going to type that in too. All right, let's take a look at what we got. So this is what I'm going to be this is what I typed into my calculator, right? So we have our equation here. So make sure we're rounding to the nearest person, right? So we're not going to have a decimal of a person. So make that a whole number, right? So no decimals. So I have y equals 50,000 1 plus 0.032, and then the thing that's new here is I'm gonna have a 10, right? Do you guys see the 10 up there? So when I type that into my calculator, right, I got 50,000, sometimes it's difficult. We make mistakes on how many zeros there are, right? Plus or times 1 plus 0.032 to the 10th power. So if I'm going to round this to the nearest person, I don't want any decimals. So it's just going to be 68,512. So I'm going to have 68,512 people. Oops. Oh my gosh. I swear guys, that I know how to spell people. Okay, what did I do? Do you see this in blue? I typed this into my calculator, just as it is. Right? So I got our equation here. This is our equation. So I just copied that down. The only thing that's new is I'm putting a 10 right here. Okay, so, and then we're talking about people, right? Yeah. And just to clarify, we're talking about people, right? So, like, you're not going to be like, hey, how many people are coming to my party? Oh, I'm going to have 0.052 people, right? People would be like, so no one's coming, right? So it's going to be, right, it's going to be that. So 68,512. No, thank you for asking questions. All right, so you guys have one under your belt today. This next one I'm going to have you guys try on your own. So let's see how you guys do, okay? Let's see how you guys do. Oop, these pages are a little stuck together. There we go. Okay, so here's your next one. I'm going to write out a story problem. You guys can write this down, okay? So let's try. This is example number 2. So we're going to have 500 mosquitoes, right? And mosquitoes, those are the things that suck your blood out, right? They make that annoying, and then they fall. Then they fall on your hand and they go, and they suck your blood out, right? Mosquitoes. So you have 500 mosquitoes are on a pond. Oops, I put pound. I meant pond. Okay, and a pond is just like a lake, right? A small lake, pond. Okay, on April 1st. And that's not an April Fool's joke, okay? So imagine you're a scientist, right? And you went out to a pond and you saw 500 mosquitoes on this day. Okay, so you went out and you collected data. And if you guys are thinking like no one does that, yes, there are actual jobs where people go count animal species. If you work for, there's a state agency that will count animals all the time. They'll count bees, they'll count mosquitoes, butterflies, fish, right? It's really important to get data, and someone has to get that data. So someone's job is to go count populations. Okay, it might be populations of deer, stuff like that. So you got 500 mosquitoes are on a pond on April 1st. Okay, the population is seen to grow by, so the population is seen to grow by 12.5% each day. That is scary. That is a lot of blood-sucking mosquitoes. You know, in Australia, they call them mozzies, right? But we're not in Australia, are we? So we got 500 mosquitoes, and they grow by 12.5% each day. I want to know how many mosquitoes. Sounds like Doritos, doesn't it? How many mosquitoes are on the pond on April 15th? On April 15th. Okay. Now, I'm going to have you guys do this one completely on your own. I'm not going to help you guys out. Okay. So because I'm not helping you guys out, I'm going to give you a bit longer time. I think this is way more time than we need, but we're going to give it to you. So as you guys are working on this, because we have 3 minutes, I want you guys to know you can ask me questions. So if you want to ask a question, go ahead and ask a question. But I want you guys to set this up, right? So think of the different steps. We're going to have to write an equation and then figure out, okay, how many days have passed, right? And then plug that into a calculator. So let's give it a shot. And if you guys have questions, I'm looking down here at chat. All you have to do is send me a question if you need a question, okay? Oh, sorry. I was talking with people in chat and I didn't realize that our time was up. Guys, so the people who were asking me questions had really good questions. The people, right? And the mistakes people were making were really good mistakes. So let's go ahead and do this problem together. And again, the more you ask questions, the more you're going to get from this, right? The more that you participate, the more you're going to get out. So let's take a look at this. Because I think some people are just making some really easy mistakes. So as we go through this, check your work, check my work, and then we'll go ahead and do this. Okay? So the first thing I'm going to do is I'm going to get an equation, right? Okay, so that's the first thing I'm going to do. So remember,
my equation is going to look something like this. And I always like to write this down because if you don't have it memorized, then you're going to forget it, right? So I'm going to start here with an initial amount. So I think my initial amount is 500 mosquitoes. So I'm going to have 500. And then I'm going to multiply that by 1 plus, and then I'm going to have a rate, but it has to be a decimal. So here's my rate, right? But I need it as a decimal. So 12.5 out of 100 is what decimal? So if I take my calculator really quickly and I go 12.5 divided by 100, I get 0.125. So that's this as a decimal. So I'm going to have plus 0.125 raised to the t. So this is my equation. Okay. So first, right, a common mistake here is, right, I'm not gonna lie to you guys. When I first tried this problem, I accidentally put 1.25. I made a mistake, right? So mistakes happen. Okay, so that's what we do first. We get our equation. Okay, so this is a common place to make a mistake. And then second, okay, let's figure out how much time has passed. So how much time has passed? So we're going from April 1st to April 15th. Now, a very common mistake here would say that 15 days have gone by, but it's not 15. If we start at the first, remember we count a day being the next day. So the next day is April 2nd. So that's 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, right? I'm at 10, 12, 13, 14, 15. So that's 14 days. Okay, and so a very common mistake here is that you look at this and you think 15, but we're not starting at 0, right? Right? So if I had 0 to 15, that would be 15, right? But I'm going from 1 to 15, that's 14 days. Okay, so I'm going to plug it in. I'm going to have y equals 500, and then I have 1 plus 0.125, and then I have to the 14. Okay, and if you type that into a calculator, I'm going to have 500 parentheses 1 plus 0.125 to the 14. Oops, didn't do that, was times 14 to the 14. And I get, so if I was rounding here, so let's think about this. If I'm rounding to, because mosquitoes, we're not going to have, unless we're killing them, we're not going to have a fraction. So if I round this to the nearest mosquito, I would round up. So I would say y equals 2,601 after 14 days. Now, I don't know about you, but that terrifies me. That's a lot of mosquitoes, right? And that's why, right, you always feel like there's always mosquitoes around if you're outside in the fall. All right, guys, how are we doing? Do you guys have questions? I saw a lot of different answers coming in. I have a feeling it had to do with this, and I had a feeling it had to do with this. Okay. Does anybody have any questions or comments? Because, yeah, I sure did, right? So if you take a look, if we're looking at this, so I have 0.79, and so if we talk here, right? If we look here, so is that closer to a full mosquito or no mosquito? And 0.79, that's closer to a full mosquito. And our rule there, if it's 5 or higher, we round up. So this is higher than 5. So we're going to round up to the nearest mosquito. Okay?
So this would be, that's why I rounded up.
Mm-hmm.
No, that was a good question. All right, so we're going to keep going here. Oops. I need to reload my questions here. So we're gonna keep practicing this. We're going to do another one
And see if we can get better. Okay. Because mistakes are going to happen. What we just want to do is we want to identify those mistakes
and make sure they don't happen again. So let's do this. So, okay.
Let's say we have
A bacterial infection.
So a
Bacteria.
bacterial infection.
Right? This is different than a viral infection. COVID is a virus. A bacterial infection is something that's growing.
So a bacterial infection of 300 bacteria. So a bacterial infection of 300 bacteria grows at a rate of 15% per hour.
Right? That's why if you ever get a cut, you need to get it cleaned right away because that bacteria that's in your cut is growing really fast. Okay?
So you're going to do,
so I want to know
how much bacteria would there be after 24 hours?
Okay, and I know that's a lot to write down. I'm really sorry. So a bacterial infection of 300 bacteria grows at a rate of 15% per hour. How much bacteria would there be after 24 hours? And I'm going to go ahead. Was 3 minutes enough time, guys? Do you guys want more or less time? Is 3 okay? Probably not less. Was 3 minutes okay last time? You're only going to get faster. You're only going to get better. So, okay, I'm going to do 3 minutes. Hopefully this was enough time for you guys to get this down. Let's give it a shot. Remember, you're going to write an equation. You're going to plug in your information, and then we'll get going. All right, guys. Well, and in this case, so yeah, so let's take a look. Let's take a look, and let's take a look at your answer as well, right? So to do this, we're gonna write an equation, right? So again, until we're like super good at this, I'm always just gonna write this, right? Plus r to the t. So I'm gonna have an initial amount, and I'm gonna have a rate, and I'm gonna have a time. So when I go to write my equation, my initial amount is, right, this is my A, that's 300. And then I'm gonna have 1 plus, and then my rate, right? So I gotta get this to a decimal, so I'm gonna go 15 out of 100, right? Like, so that's gonna be 0.15. So I go 0.15, and that's to the t. So there's my equation. Now be really careful right here. This is a place a lot of people can make mistakes, right? With writing this as a decimal. So then next we got to say t. Okay, so t is in hours, right? And so it's 24 hours. So when I go to do this, I'm going to go y equals 300 and then 1 plus 0.15 to the, and I'm going to put 24. So I get 300, then I have 1 plus 0.15, and then to the 24. Okay, so I'm going to type that in, and that's what I get. So now, if I'm talking about bacteria, I'm probably not going to talk about fractions and stuff, okay? So what I'm going to do is I'm probably going to go to whole numbers on this. I know it didn't say, that's really not nice, right? I didn't say that. So if you got to here, consider yourself good. But I'm going to round this to the nearest whole number. So see how this is 5? I'm going to round that up to an 8, okay? So when I go to write this, I'm going to say there would be, what number did I get? So 8,580. I said I was going to round up, didn't I? 8. So I rounded up. Bacteria after 24 hours. Right? So do you guys see how that really took off? That's a lot more bacteria, isn't it? Which is why if you ever get a scrape, an open wound, right, where blood's coming out, you always want to clean it right away. Or else, if bacteria did get in there, if you wait until the next day, you could be in a really bad spot, and then you have to go to the hospital, right? And that's not good because there's some really bad bacteria out there. Okay, so let's just pause for a second. Do you guys have any questions or comments or concerns about that? Hopefully what you guys found is that even if you didn't get all the way to the end, you're making progress, right? Because this is our 3rd day doing this. So hopefully you guys are making some progress and you're feeling a little bit more comfortable with this, okay? So in your homework tonight, you're going to have, this is going to be your first homework where you're going to have a word type problem. Remember, there's 2 steps, right? So first, right? First, write an equation. And then second, plug it in. So there's 2 steps. 1, write the equation. 2, plug in that value. Okay? You guys can do this. I believe in you. Okay? Starting next class, we're gonna spend 3 days, guys, on just focusing on decay. Okay? So we did growth, right? So in growth, you see how we're adding a rate? All we're gonna do differently with decay is we're going to subtract a rate. And that makes sense, right? We're adding more, and a decay will be subtracting more. Okay, so really, that's all we have today because it's 9:45. We don't really have time to do one more, or do we? Maybe we could do one more. Okay, so maybe we can do that. Let's do one more. One more. Okay, so here's our last one. So let's say we have, let's do another bacteria one.
So this is example 4.
So let's say we have, so
500 bacteria grows at, and this is going to be a different rate, 21.3% per hour. How much bacteria after 18 hours?
Okay, let's give that one a try. And we don't have as much time, so I'm going to cut the time off just a little bit. So I'm going to go 2 minutes, 30 seconds. Okay. All right, so you have 500 bacteria. It grows at 21.3% per hour. How much bacteria after 18 hours? Let's give it a shot. All right, guys. We don't have a lot of time left in class, guys, so I'm going to go through this. Oops, I'm just going to throw my paper on the ground, apparently. I'm going to go through this really quickly. And if you have questions, you can stick around and we can go over it together.
So my equation here is going to be y equals my initial amount. And then I have to write this as a decimal, so it's going to be 1 plus 0.213 to the t. Right, so I did 21.3 over 100 equals 0.213. Okay, so this is my equation. And then I'm going to, right, like that. You got it. Okay, and then it says after 18 hours. So I'm going to go y equals 500, 1 plus 0.213, and then I'm going to go to the 18 hours. I'm going to type this into my calculator. So I get 500 times the quantity of 1 plus 0.213, and then take that to the 18th power, and I get this. Now, when I look at this, I'm going to, I see this is 5 or greater. I'm going to round up. So, oh my gosh, this is a lot of bacteria. So I'm going to get 16,161 bacteria after 18 hours. Okay. So that is that, guys. This would be our answer.
That is the end of class.